So let us consider this scenario. Let us say there are 10 processes which are running in the computer for as of now in the system. Then what happens is, for each process, in order to run it, we should always have its page table in the main memory. Then how many page tables have to be dedicated? Even if you think that each page table is one page, then we have to have 10 pages dedicated only for the page tables of the processes, and which is going to take up a lot of space, right? Then what people thought is, even though we have these many processes and even though we are having these many page tables, all the pages are not going to be present in the computer at any time. So the number of pages which will be present in the computer at any time will be equal to the number of frames in the main memory. So depending on this, what they did is they have generated something called as introduced something called as inverted page table. So if you know the normal page table, it looks like this. See this? Maybe the normal page table looks like this. This is the page table I am talking about, right? So the number of entries in the normal page table will be equal to the number of pages in the process. So this is page number 0, page number 1, page number 2, page number 3, page number 4, page number 5, page number 6. These are the page numbers, right? And now inside this there will be frame numbers like frame number 1, frame number 2, frame number 3, right? Let us say this is page table of process P1. Page table of process P1 is containing these, these pages of process P1 are present in these frames, and all the remaining are not yet present. They are all absent. Okay. And similarly, you might have one more page table of some other process which is running in your system. Let us say this is page table of process P2, and again it will contain many pages like page number 0, page number 1, 2, 3, 4, 5, 6, something like this, right? And now the second page, the process P2, the pages of process P2 might occupy some other frames. Let us say this is present in frame 4, and this is present in frame 5, and this is present in frame 6, and all the others are not present. Now at any time, if you observe like this, all the processes which are present in the computer in your system, now the page table will contain only the information for the pages which are present in the main memory, right? So if a page is not present in main memory, that information will never be present there. Even though you are dedicating this space, that is just a wastage. So what people thought is, instead of having one page table for every process, let us have only one page table for all the processes, and the entries in that page table will be equal to the number of frames in the computer, which means they have invented or introduced this new concept, so which is called as inverted page table. Inverted page table. Why is it inverted? Is in the normal page table we are going to use page numbers as the indices, right? But in inverted page table we are not going to use page numbers as indices, we are going to use frame numbers as indices, frame numbers, right? So which means frame number 0, frame number 1, frame number 2, frame number 3, 5, 5, 6, 7, 8, so on, right? Like this we are going to use it. Then the concept is like this. Now see this. In frame number 1, page number 1 is present of process P0. So frame number 1 contains page number 1, isn't it? And then frame number 2 contains page number 3. So frame number 2 contains page number 3, and frame number 3 contains page number 5. Page number 5. And here if you watch it, frame number 4 contains page number 2. And similarly frame number 5 contains page number 3. And frame number 4 contains, frame number 6 contains page number 4, right? Like this. So they are maintaining as indices the frame numbers. The reason behind it is, at any time the number of entries we might have to maintain are equal to the number of frames which are present in the main memory. You cannot have more pages than the number of frames in the main memory. That is why they are having these many entries in the inverted page table. Got it? And next thing is, if you observe it, there is a confusion here. Page number 3 is present here as well as page number 3 is present here. Now what is this? Two pages of same number are present here. So just to resolve this confusion, along with the page numbers, we have to even maintain the process IDs. Process IDs means which process does this page belong to, which means if you watch it, the frame number, this 1 2 3 belong to the process P1 P1 P1, and about this next one, they belong to the process P2 P2 P2, right? Therefore, how do we search it is, whenever CPU generates logical address which contains page number and then page offset, this is the logical address, right? And now earlier we used to take only the page number and go into the page table, right? Because we are sure that when we look into the page table, it contains the entries of only one process. But now when we go into the inverted page table, it might contain the entries of many processes. That is why, even though we are having only page number, so we are going to take page number, along with it we will be taking the process ID, and then we'll use it and we'll go and check in every entry. We have to check in all the entries. We cannot index into the inverted page table because we don't know where this particular page is present. It can be present at any point, right? Therefore, we have to simultaneously check all the entries continuously, right? And we have to check whether for this process number, this page number is present or not. For this process number, this page number is present or not. For that, it is going to take a lot of time. And remember, this is just a normal memory, not any TLB. Therefore, searching is going to take a lot of time. In case if you maintain it in TLB, yes, it could be faster. How? You can maintain this in TLB, right? And then you can have tags, and the tags will contain process number and then the page ID. But then that will again reduce it to the normal TLB. So anyway, this is normally kept in the main memory itself, right? So searching is going to take a lot of time. So this is not generally used. I mean, even though this concept has been proposed, this concept is not widely popular because it is able to save this space for sure. Because if I have 10 pages, see, if I have 10 processes, I might have to save 10 page tables, and it's going to take a lot of time. But now if I have inverted page table, I have to have only one page table, right? So space is going to be reduced depending on the size of the page table and inverted page table, but then the time is going to increase, and so people don't really prefer this. Yes, this concept is introduced, but we are not really preferring it. Anyway, I'll just take a question, I'll just give you some question, answer it. Let us say physical address space or physical address is 32 bits and the page size is 4 KB and inverted page table entry size is 4 bytes, then what will be the size of the inverted page table? What will be the size of inverted page table? Can you solve this? Okay, so if you observe this, the size of the inverted page table depends on number of frames, because number of entries in the inverted page table will depend on the number of frames in the main memory. Therefore, size of the inverted page table depends on number of frames in the main memory, right, into page table entry, inverted page table entry. Now you have to find out the number of frames in the main memory. If the physical address space is 32 and the page size is equal to frame size, isn't it? Page size and frame size is 2 power 12. Then what will be the number of pages? You divide 2 power 32 with this. You will get that number of frames in the main memory is equal to 2 power 20. Because this is 2 power 12 and this is 2 power 32, therefore you will get 2 power 20 frames. If you have 2 power 20 frames in the main memory, isn't it, then how big will be this inverted page table size? 2 power 20 into 4, right? 2 power 20 into 4, which is nothing but 1 MB. Got it? So 1 MB is going to be the size of the inverted page table. So I mean, there are no questions on this because we don't really use it. It has never been asked in GATE, but anyway, it is worth knowing about it. Okay, fine. That is all about the inverted page table.